Assalamu alaikum. Hi students, this is Majid Tahir. We are doing computer science. So let's start number systems. Here we are. We have binary number system in hexadecimal. Let's start with the binary number system. Okay. So what are binary number systems? Basically, we humans, we work on the number system is the binary number system, or we call it decimal number system. So what is decimal number system? We do all the transaction, calculation, everything, whatever we do is in the binary number system. Basically, you can see this is what the binary number system is. The possibilities are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. Any number that you can think of is going to be between these possibilities from 0 till 9. So we have this thing is called base. Because we have 10 possibilities, we have base 10. Okay. In your early classes, probably you have done the place value. So here we have the place value. When we have bases power 0, the place value is 1, or we call it unit. Then we have tens place, then we have hundreds place, we have thousands place, and we have 10,000 place, and so on. So place value keeps on increasing with the base power. We have 10 power 0, 10 power 1, 10 power 2, 10 power 3, and so on. Okay, how do we calculate in the number system? If we have, for example, you can see we have a number 6,432. How this number is made is basically this 6 is multiplied by its place value, which you can see over here, 6 into 1000. 4 is multiplied by its place value, which is 100. 3 is multiplied by its place value, which is 10, and 2 is multiplied by its place value, which is 1. So we have 6,432. We even read it as it is 6,432. Now coming back to the binary number system, let's see what this binary number system is. Okay, now we are going to do binary number system. What is binary number system? Binary numbers must be converted into their binary equivalent before a computer can use them. What is binary? Computer use binary digits 0 and 1 to store data. So computer's processor can process in only zeros and ones. There are billions of transistors. A transistor is a tiny switch that can be activated by electronic signal it received. So when it is activated, it receives current, it's 1, or it's on, and we perceive it as 1 in binary. If it is off, or it does not have any current, it's off, and we perceive it as 0. So binary reflect on and off states of a transistor. So that is why we have zeros and ones. And because there are only two possibilities, either 0 or 1, or off or on, only two possibilities, so its base is 2. Now because these are only two possibilities, its base is 2. There are only two possibilities, 0 and 1, so its base is 2. And we have the same formula that we were using in binary number system. Base is power makes the place value. So 2 raised to power 0 is 1. Always there is going to be a 1 place value. 2 raised to power 1 is going to be 2. 2 raised to power 2 is going to be 4. 2 raised to power 3 is going to be 8, and so on. In binary system, easy thing is that the next place value is always double of the previous one. For example, we have 1, we are going to have 2, and then we have 4, we have 8, we have 16, we have 32, 64, 128, and so on. Next place value is going to be 256. We have hexadecimal number system. We will talk about later on that why do we use hexadecimal number system. It's base 16. Basically it has it starts with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have A, B, C, D, E, F. What is A, B, C, D, E, F? Basically A represents 10, B represents 11, 12, 13, 14, and 15. Because these are 16 possibilities, its base is 16. The same formula, 16 raised to power 0 is going to be 1. So its place value is 1. 16 raised to power 1 is 16. 16 raised to power 2 is 256, and so on. So it works with the same formula. Thing is, we are going to convert from one number system to another number system. So we are converting from Denary or decimal number system to binary conversion. Okay, now we are going to start Denary to binary conversion. In Denary to binary conversion, we have two methods. First of all, we are going to see method number 1. In method number 1, we divide number by 2. So this is the process. Let's suppose we have number 83. When you divide 83 by 2, because it's a odd number, you will always, whenever there is going to be an odd number, you will have 1 in the remainder, and when you have an even number, it's completely divided, so you are going to have 0 in the remainder. So 83 divided by 2, you get 41, and remainder is 1. Further, 41 is divided, you get 20, remainder 1. You divide 20, you get 10, remainder 0. And again, you get 5, remainder 0. Again, you divide 5, you get 2, remainder 1. Further, 2 divided by 2, you get 1, remainder 0. And then if you further divide, you get 0, remainder 1. So we write 1 0 1 0 0 1 1. If you want to write complete 1 byte, so these are 7 bits, you can put a 0 over here, it's going to be fine. Okay, next, method 2, we will use the place values. For example, we have again we have number 83. 83 has to be we have to find equivalent binary of 83. We will write the place values 1, 2, 4, 8, 16, 32, 64, 128. I have to see that what I can add to make 83. So I'll select 64, 16, and 2. 64, 16 makes 80, and 2 and 1 makes 383. I'll put ones underneath the place values where I have which place values I have selected. I'll put 1 over here, which make 83, and the rest I will put 0. So the number you get is 0 1 0 1 0 0 1 1. So this is the method 2 for converting Denary to binary conversion. Binary to Denary conversion is also very easy. For example, you have a binary number 1 0 1 0 1 0 0 0. Now you have to find out, this is the process given. Let's see this process. We have to multiply every number with its place value. Let's write the place value above: 1 2 4 8 16 32 64 128. Now 1 multiplied by its place value will give an answer exactly like a place value, and anything multiplied with 0 will get 0. So we will just select the numbers with ones. So I'll write 128 plus 32 plus 8. I'll add them, I'll get this number 168. So this binary converted to Denary is this. We have again binary to Denary conversion. So same thing, same process what we have just discussed. So you write down the place values and you select. For example, we have to make 168. I've selected 128, 32 and 8. That makes 168. Rest I'll put 0, and this is my equivalent Denary number 168.